Let me say a few words before you start. So welcome to the show, everybody. So today's talk, Gurja will you be everything or shall I also switch? So Gurja will talk about the new NSF project, and it's an MRI project, so major research instrumentation. So it's not a grant to do research, it's a grant to develop an instrument for research. And we just, I mean, the money came in last semester already, but for this one, you also need match-up from the university, and there's all kinds of delays. So we started officially sort of last week, so had the first meeting last week. So that means that a lot of things can still be changed, but so we have some initial ideas what we want to do. Of course, we have also made promises to the NSF, right? So we have to stick on background, right? So if somebody says, hey, you know, why don't we take the money and we buy a nice car, a nice sports car from that also. That is a wonderful idea, but I'm afraid the NSF will not let us do that. Right? So, but really the idea is here now to present the project and say, hey, this is what we're going to do or what we plan to do, and get some feedback and get some ideas. So it's really, we are at the very beginning. So nothing is other than we have to make a camera array, so don't suggest a sports car instead. So that's where we stand, and Gurja will take it from there.
All right. Good morning. I'm Jia Guo. I'm working with Dr. Cordilla and Dr. Mueller in mechanical engineering. Today, I'm going to talk about our NSF MRI project. This topic is to build a high-speed video camera array for capturing animal motion kinematics. So our goal is to build a generic motion capture system to observe and measure various motion of animals. So we want this system to be useful for different studies of animal locomotion. To achieve the best quality of measurements, a higher resolution is preferred. However, the resolution can be thought from two ways. One is spatial resolution, another is temporal resolution. The spatial resolution is basically the resolution of images, like how many pixels in one image, and the temporal resolution is achieved by increasing the frame rate. Usually, there's a trade-off in the area of high-speed photography. If you want to get higher spatial resolution, which is image quality, you have to sacrifice the frame rate. If you want to reach a higher frame rate, you have to compromise on the image quality. So we want to find the best combination for our research to capture the animal locomotion. And also we want this system to be free from the self-occlusion. This is an annoying problem in animal motion capture.
Can you explain what is self-occlusion?
Self-occlusion is that, like, if you're observing, like, because the animal is moving in an arena or tunnel or whatever, we place markers on its body so that we can measure them. Sometimes it'll block the marker from some cameras.
In short, it's if one body part of an animal covers another body part. Right? So one leg is behind another leg, or one wing is behind another wing, and so you don't see it. Right? That would be self-occlusion. Occlusion would be, say, if a lizard runs on a branch and the branch covers part of the lizard. So that's the idea.
Okay, so the newly proposed system comes from our experience on working with our the pilot system. In this system, we use 30 GoPro cameras, and they are distributed on 4 rings, and each ring has about 7 cameras, and the 4 rings are the ring has the diameter of each ring is about 1.5 meters. The 4 rings are placed along a structure, basically a flight tunnel. We built this tunnel to study the flight motion of a kind of bat. So the cameras are connected with the Ethernet cable and an extension chip. They're synchronized and controlled. They're synchronized and controlled by a line driver, which was designed by us. So these cameras can record 720p videos at the frame rate of 120 frames per second. This system provides some good results, but the low frame rate and the issue of self-occlusion make it very difficult to run our auto point tracking algorithm. So so I want to mention that the automatic point tracking is very crucial in high-speed photographies. Like, for example, let's look at this setup. There are 30 cameras, and each camera is recording at the frame rate of 120 frames per second. If all of those cameras record for 1 second, there would be about 5,000 images produced. And in each image, there would be about 200 markers to be tracked. So in this way, to track all these markers, there would be 1 million markers to be pointed. It's impossible to be finished by hand. We have to develop a program or something to do that. So in this project, we split the design work into 2 parts. So the first is the optical design. In this part, we want to find a suitable camera that balances the frame rate and the image resolution. We also need to select the lights carefully. On the one hand, the lights are necessary for photography. On the other hand, the strong lights might generate high temperature, which may affect the motion of animals. So the second part is the mechanical design. We want the system to be available for various studies of animal locomotion. So we prefer a flexible design. We plan to build the frame with an aluminum frame with multiple possible configurations. Also, we need to come up with the scheme for positioning the cameras and lighting, because this might be the most reasonable way to get rid of the self-occlusion. The third part is electrical design. In this project, we plan to use 50 high-speed cameras, so we have to come up with a scheme to connect all of them, so that we can control and synchronize them. Probably we're going to design. We plan to design some line driver to achieve this. Yep. And the last part is software development. So in order to measure from the stereo vision, we need to know the relative orientation and position of the cameras. That requires a calibration software. And also, we want to compute all the 50 cameras simultaneously instead of turning them on one by one and repeat that 50 times. we want to control software. Then we need image processing and motion estimation software to post process the experimental data, and then and finally we want to develop a software to visualize the results of so that the analysts can do their job. Oh, I didn't put the picture of cameras we're using in this slides. Let me.
That is the camera.
Oh yeah, that is the camera. So this camera is developed. It's called. No, it is developed by Crontech. I forgot its name. It has.
The camera is called Kronos. Is the name of the camera. And the company is called Crontech.
Yeah, it's called. It's developed by Crontech. It is equipped with the 2/3 inch CMOS as the optical sensor, which is slightly smaller than the most common cell phone camera. It has an interchangeable lens mount. It is adaptive to all the CS mount lenses and the C mount lenses if we have an adapter. So the most amazing part of this camera is its resolution, especially the temporal resolution. It can reach the frame rate up to 1057 frame per second at the image quality of 1280 by 1024. This image quality is even slightly better than our GoPro, than the GoPros in our pilot system. But you can see this in our pilot system, the frame rate is about 120 frames per second. So this camera allows us to increase the frame rate by 10 times. It also records at 2,800 frames per second at 800 by 600, and even 6,000 frames per second at a more compromised image quality. And from that table, you can see the trade-off between the spatial resolution and temporal resolution. But we believe this combination is what we want. So the high frame rate allows us to handle much more complicated situations than our pilot system. These two figures come from a paper of Matt Bender, one of our leading developer of the pilot system. It shows the typical results when recording a fast motion with low frame rates. These figures are 2 consecutive frames in the video. The dashed curve in the second figure shows the same position that is shown in the first figure, shown by the real curve. You can see the displacement under such low frame rate. The displacement is very large. That makes it very difficult to recognize the correspondence of markers, even for human. But to automatically track the points, with such low frame rates videos, we have to resort to the kinematic knowledge, which is unknown to us when we take these videos. So now imagine we can apply our new cameras, which has 10 times higher frame rate. That means that we will have 10 more points on each segment. In that way, the displacement will be reduced significantly, and hopefully we can track the points automatically under such high frame rate. Here's a demo video taken in China with the camera. It's a bat flying through the tunnel. You can see how smooth the motion is, and we can see everything clearly.
Is the Chronos camera a color camera?
It has two types. One is colored. One has colored sensor. One has monochrome sensor.
And this is done with the color.
Yeah.
Yeah, but is the plan to get monochrome?
The decision has not been made. We have 3 color cameras, and if from the tracking we should get a demo camera, a monochrome one next Monday. And the idea is then to see what. So the advantages of a color camera is obviously that if the animal has some natural color contrast, like part of it is red and part of it is green, then you can use that and work with that, or you could put markers on in different colors. Whereas if you use monochrome, then it's only black and white.
But you better ISO.
And
yeah,
exactly,
the
and then you have on the other, so there's where there's an advantage, there is also a disadvantage. So what we want to do next week, when we have also a monochrome sensor, we want to sort of benchmark the cameras against each other and then see if finally the advantages on the disadvantages, in which direction to go. So the idea is we get the same, we get 50 times the same. We have a few color cameras for sure, but we have those 3. But we will buy 50 cameras that are the same, and it will be either color or monochrome. And if you feel strongly about that, or you have any input, then maybe say it now, because then we might be able to accommodate it. But really, we want to wait until next week so the company has 2 images on the website where you can see, and you can see that indeed the monochrome color gives the nicer, the quality other than color representation is better. But we really want to sort of have a mock bet and sort of time. If you are interested, you will want to do some testing, maybe you can connect with Guojia or Xiaoyan. Yeah, they are the team. And maybe you can join us next week and test something, right? If you want to see it yourself, we can do that. Right? So we want to make a decision after having seen the data.
Yeah, we need some experienced photographers. Yeah. Okay, so this is one complicated situation, the fast motion. The other situation is the membrane deformation, because the deformation usually has infinite dimensions. So to study membrane deformation, it's better to place dense markers on the membrane. But that in this situation, we will face same issue as in the fast motion, because the dense distribution of markers is even less tolerant to large displacement for recognizing the correspondence.
Is that because of the size of the markers?
No, because of the distance between 2 markers. If the displacement is too large, it might, this marker might move to this one, but the computer cannot recognize that. Yeah, similarly, this issue can be addressed by the high frame rate. So I would like to show you automatic point tracking software we developed for the high-speed camera. And this software is developed by the courtesy of Peter Windus, and I updated with some optical flow algorithm so that it can track markers automatically. Is it moving?
Slowly.
Oh, okay. Yeah, you can see with this video is recorded at 800 frames per second. So you can see this automatic point tracking can be achieved nicely.
So that is yet another high-speed video camera, right?
Yeah, yeah,
but not this one is another high-speed video camera. That is that.
Okay, so besides the improvement in the frame rate, and this proposed system can be customized to adapt to different research requirements. On the one hand, we can design our own structure with the detachable parts. On the other hand, the lens of this camera is interchangeable. There are many different kinds of C-mount lenses in the market, so we can choose them if we can buy them if we need.
Yeah, so maybe I can also briefly interject here for people who do recordings themselves. But so Kronos offers three different lenses that they sort of sell with the camera. And two of them they think might be good for our application. One of them, I think, is a 12mm lens is lying here for the demo unit that will hopefully arrive on Monday. We will get the other one, so we can test those against each other. And of course, since this is C-mount, we could also go for another lens. So if somebody has some thoughts on that, or has a lens that you say, here, I have a C-mount lens, and why don't you try that? That's all possible. But we would have to watch the budget, but because when we made the budget, we budgeted buying one of their lenses, and the two versions they cost the same, so it doesn't matter. But if we went to another vendor, maybe GoPro, and not GoPro, Kronos would be a bit unhappy if we don't buy the 50 lenses, but they get a lot of money from us buying the 50 cameras, so I think that would be okay. But so let us know if somebody of you has experience with lenses and say, you should really do this or you should do that, and that's still possible.
Yeah, so if you want to zoom in, you can choose a telephoto lens. If you want to record motion in an open space, you can use the wide angle lens. Yeah. So I would like to emphasize the flexible design of the frame. There are already mature products and schemes in the market so that we can design our structure with to fit in our requirements. So we can take this advantage and customize the frame. This is what we used in our pilot system. It's just a conventional, traditional tunnel.
It's a rectangular frame.
Yeah, it's a rectangular frame. We can brainstorm and come up with some novel structures like that. This is a structure inspired by the fullerene, some chemical structure. We can build the tunnel like in this way, perhaps because that provides different perspective for the cameras, and hopefully. Probably, I wouldn't say hopefully, probably it can avoid some self-occlusion.
So the idea is to find a way to distribute the cameras really equally on the surface of that cylinder, as opposed to now we have rings, right? So the cameras within the ring, they tend to be very close together, maybe unnecessarily close, and then between rings you have larger gaps. And so we want to come up with something, and again, ideas here are welcome. We want to come up with something where the cameras and the lights are distributed more equally.
Will that complicate the calibration aspect of different?
No, the calibration process will be
the
the
same.
same. Yeah.
Yeah, because there's actually so nice methods where you can just wave a laser pointer through and you take a lot of pictures, and then there's a program that churns on all those data and it comes up with the calibration. So it finds the relative position of the camera, it recovers that as well. So that can be, and we also we are looking for ideas. So for the beds, what we have done in the past and what we will probably continue to do is just have a horizontal cylinder. Right, at the bed slides for the middle. That's why we put the buckyball there. Right, so the idea is we could also make a dome. We could use the full ball, or we could make a half hemisphere. We could make more. Maybe take the cylinder and put it vertically, right? So that maybe a parachuting animal like a frog or so could parachute through the middle. We could think of tilting it a bit to the side, right? So there's possibilities here, and if people have requirements or inputs, we can see there's maybe some things that we could right away build in, or some things that maybe we could leave open as a possibility, but would need additional effort. So that this all things that we can discuss at this stage, right? That's why we just wanted to toss out the idea. We're looking for something more creative, right? So no rectangular films anymore. Also for this system, right? How do we do these arbitrary angles or wider range of angles? That hasn't been decided yet, so these were just some commercial examples that allow you to do that. But we also will still take suggestions for how to best make that frame.
All right. So with the when we take the advantages of high frame rate and customizable structures, there will be this system can be used in very wide areas. Like we can use it to study almost all the animal locomotion we can imagine, like skating frogs, flying or gliding snakes, running lizard, diving birds, flying bats, and the drinking motion of bats with its wing, and probably also the swarming behaviors. So it's more like a photography studio, but not for human. Instead, we do that. We take pictures and measure that for animals. These are the these three pictures are the illustration of the potential uses. And this is for the bats. Okay, now. Now let's go back to this camera. This camera has lots of ports for you for electrical guys to extend them. It has an HDMI, audio input output, USB, BNC, mini USB Ethernet. Aux input output, and power input. I'm not quite an electrical engineering person, so I would leave that to electrical engineering student.
So does this camera have jet locking, or?
Sorry?
Does this camera have jet locking? Frame syncing?
Yes.
Is it done through BNC, so it's
Yes.
trigger and that's both done on the BNC line?
Yes. Yeah, it has an analog trigger, and with that you can control the equivalent of a shutter. Right?
Okay.
And
I'm
that's
just wondering how the trigger and frame rate is encoded on the same and one BNC line.
I don't know if this figure will help you, will be helpful for that question. This diagram shows the trigger input output circuit.
So the promise is, so how it's realized, we don't know. Maybe we want to look into it. But the promise is that what is in 10 picosecond accuracy, you can synchronize the cameras. So
Okay.
the frames will be taken. That's what the company promises within 10 picoseconds. So all 50 frames would be within a time window of 10 picoseconds. That's the promise.
You can measure.
Yeah, well, yeah, and we don't even know. We will never know if that is true. But we will probably we need less precision. But that is how the system is actually supposed to be designed, and that's why we went with this camera. So if you look at the market for high-speed cameras, right, they are the really expensive. So these are the basic camera. I think it's about $3,000 per piece. And then if you want the memory extension, 16 gigabyte, that costs you extra, and the lens costs you extra. Right? So if you add that up, you get somewhere 3,600 or something like that for camera. So there is the, but
It's pretty cheap.
it's pretty cheap, right? So I mean, I also remember in my youth, the high-speed cameras, they started sort of $20,000 and up, right? So and then when we put in that proposal, we saw this opportunity. There's a couple of companies, 3 that I know of, that started on Kickstarter or something like that and said, hey, let's make something in between the GoPro and the real professional or high-end ones. And so we feel this is good. And we picked this company last not least because they have a mature triggering support and the ability. And the company is actually, and so when we approached them about a year ago, we said, you know, we want this project, apply for it. And they said, yes, we are very interested in that because we want to make sure that works, because then we might be able to serve other customers with that. So we have, in a way, the company as our partner here. And we had 3 cameras in operation, synchronized in the summer for bad drinking behaviors. Do you have any of those videos? Will you show any of those?
No, I don't have those.
It doesn't matter, right? So you've seen one and one flying through the tunnel. So we know it. I mean, I cannot guarantee the 10 picoseconds or whatever it was, but you can really see it seems to work. But that's what I can tell you.
Yeah, and that's it. We would like to thank the ASF.
These grants are also wrong, right? Yeah. That was just copied and pasted from another grant, right? It's just one MI grant.
Okay.
But you still should thank the NSF for that. It's only one grant, and neither of the 2 is the number I collected.
All right. But that's my bad.
It doesn't matter. There's one NSF MI grant, and we definitely want to thank them for that.
Yeah. Okay, thanks. Any questions?
Mm-hmm. So with better spatial resolution, so in the previous markers that you have on the battery, all of them are circles of the same radius, right?
Yeah.
Do you have plans of like changing the shape of, say, a row of rows so that you can avoid occlusion errors?
Yeah, that's possible. That's possible, but it's kind of difficult to achieve because you see the markers. You see from the screen the markers seems to be big, but actually those the diameter of those markers is about how many 1 millimeter or so, that big.
Yeah, I mean, we have tried it before. I mean, the idea, by the way, it would not be for occlusion, right? It would be for counteracting confusion, right? So if you had 2 types of markers and you would alternate, right, between the dots and the stars or something like this, or you had 3, right, then the software could hopefully pick that up and say, this cannot be the other one, right? Because the neighbor would be different. But the problem is indeed, how do you make those different shape markers and how do you affix them to the bed? So at the moment, these markers, they are little drops of white out. What is that?
Yeah, well, actually, there's a couple. We've also used some white medical tape.
Yeah, but didn't they always fall off the surface? There was still something you currently did?
Yeah, well, there's been a couple different generations of it.
Yeah.
Really both.
They both work?
Yeah.
Okay, so maybe then we had that one point, right, like so when you punch these things out. So so if that's working now, my sense was that these markers, they tended to fall off.
They use like a stencil of rows of, say, stars and
exactly
scraping them.
Yeah, that's we have done exactly that, right? So there's 2 problems. There are 2 problems. One problem is that getting those things to stick on the bed, in our case, didn't work so well. So you always, but imagine we put about 350 markers on the bed. So if 10 fall off, right, that's not so much, right? It's just 3%. So Peter seems to say that it's worked out now, so they are sticking better now.
Yeah, I mean, they're pros and cons to each one.
Yeah. And then of course you would have to come up how to make the different shapes. I know we had in the past even making circles was sometimes a bit tough, and you know that you have these hanging chats and it doesn't. So but it's definitely something to revisit and see. Like with different colors, we also have tried that, and I mean that's another thing with even with the color cameras. That it wasn't all that good, right? So getting a really nice different color signal didn't also work all that well. So although you put them red and yellow, they still look in this lighting conditions, they tend to look all the same. So these are things that definitely can be revisited, and you know, it's obviously, I mean, you know, we come from a civilization that has shot a rocket to the moon, right? Why should we not be able to make little markers of different shapes? That is, it's just work, and so we'll see if it's necessary, right? So here now the idea is really have a high enough frame rate that from frame to frame these markers move so little that there's no way to confuse them with the next marker, and that's sort of a fool-safe way of doing it. And at the moment, that's what we think, right? That we say, okay, you can just take a block of white out, put this little thing on there that goes very nicely. It doesn't go off in the experiment. So at the moment, that is the thinking how we want to use it. But you know, there might be different ideas in the future, and of course, it's having more information never hurts, right? So these things can also be added. But I feel, based on the experience that we have with the current setup, if we increase our frame rate from 120 to a bit more than 2000, that would make it's a big game changer, and would make it, because yes, again, as I think Roger has pointed that out, but if we run 50 cameras and we run them at 1,000 frames per second, a bit more than that, that means we have 50,000 images in 1 second, right? So if the animal makes a little flight maneuver, 4 seconds, 200,000 images, right? So now you really, there's no way you can do it by hand. And even if you get errors, right? If your error, right, if you have 1% error, that means in 1% of the frames you have a misidentification. That means you have 2,000 frames that you have to manually fix, right? So we really have to have an error rate maybe 0.1, 0.01, right? That would be 20 frames. That's something. So you know this number. So how much manual fixing do you have to do at the current recording?
Too much. Got gray hair
doing this. So ask him.
Yeah.
I remember you gave me a calculation of how many hours. So it was 1,000 hours or something. Or
yeah, I mean there are a lot of areas.
Yes, I remember that too, but I forgot the number.
Yeah.
Yeah. So we had, how many frames did we have?
So we have around 200 frames.
200 frames,
Yeah.
and there are how many points in each frame?
About 250.
250.
Yeah.
And at the current state of the technology,
Yeah.
I remember the number 1,000 man-hours to go through all the frames, fixing it, and so on.
Yeah, I think it would be
With the GoPros,
With the-
at
yeah.
120.
Yeah.
So the automated recognition, it helps,
Yeah.
but you still need a lot of effort to fix errors.
Right.
And then so the idea here is going up with the frequency and the image quality. I mean, the image quality goes also up. So this camera has a much better, I think you have seen it from the video. So we have not only a higher frame rate, but also at that higher frame rate, we still get a better image quality, right? Better resolution, better contrast.
That's one question. So one of the things I noticed, I saw the videos which I think Peter had made with the high-speed camera in summer. And one thing I noticed was when it is in focus, things are extremely clear, but it doesn't take a lot for the back to move out of that focus. So my question is, I don't know the technical term that you would use to describe this, but is it the field of view? What is it?
Yeah.
Depth of view.
Depth of view.
Depth of field.
Yeah, and I find that much less in these high-speed cameras than the GoPro
Well,
Because
that all
GoPro-
has to do with the lens.
lens. Stuff.
So what you need to do is have more light and stop down the lens, and that will increase the field of view. So really, the more light, the better, and that's one of the reasons why having a monochrome camera would be better, because you have better ISO. So you'll get a lot more. You'll be able to stop down the lens much more, and in general, have a much higher depth of field than with a
I
color
think
camera.
that's
At all.
that is one thing you might want to consider.
Yeah, that's good, and that's a point that we will do in the testing now. So the lens and also the geometry of the array, I think we will now go bigger. So the plan is now to make it maybe for the jet configuration, to give the whole thing 2 meters diameter. So we would hope that we can have reasonably sharp pictures, say maybe from 50 centimeters away to the camera to about 1 meter 50. So you have a 1 meter range where the bat can fly and is reasonably in focus. But that's something next week we have to test that.
Test it with an opening umbrella.
Light will be a huge
Black
problem.
color umbrella dots on the other side.
You need to prevent shadows too.
Exactly. Right. So we want to test them. So indeed, we are not thinking of an umbrella, but maybe a little cardboard bat with dots, and we want to see. It's a very important. So again, you're welcome to join, right, and see how these things are. Peter, if you are curious, right, and may want to see how it compares. So next week, camera should come on Monday. I don't think we'll do anything before that because we really want monochrome and color, and we want 8mm lens versus the 12mm lens. Do you have any lenses in your lab that have C mounts?
All our Vicons have C-mount lenses, and I think they're 12. I have to check.
Maybe you want to check what you have in your drawer,
Yeah.
and if they have C
But
mounts.
most of our lenses are F mount. So most of our lenses are F mount.
Okay.
We have a C to F mount adapter.
Okay.
Connect the lens.
Yeah. So it's just a connector. So if anybody has any suggestions on lens, or you have lenses, and they have a C mount, or you have an adapter for C mount, or you have a F mount, a C mount adapter already, but then next week we can try. Right? We can experiment and see, right, what do we get, right? So we need. It's a good point, right? So you cannot, if you have an animal move, but first of all, the animal has a certain depth, right? There's the left wing tip, on the right wing tip, and the left wing tip, and they will be at a distance. And it's also hard to force them to be exactly in one point, right? You cannot say, dear bat, if you fly exactly here, you can do a little bit, right? We could have little wires, and we want to force the bat on a certain path, but and we want to make it a turn, right? So if it makes a turn, it has to be more on one side as it flies in one direction, and then as it turns, it will probably come more on the other side, right, until the turn is complete. So we have to set it up that we get some coverage, right?
So in this testing that you're going to do next week, are you going to put markers and stuff like that?
Yes. So the idea is to make a little cardboard back, right, and then put white out markers on there.
So you would have frames and videos and so on.
Yeah.
Of that.
Exactly. Yeah. And then so if we don't find anybody to present here, then we'll probably come back with it and do another session here if nobody else wants to give an exciting thought. Or maybe we should do it anyway, right? There will be an update, and yeah, so that's the idea, right? So to recreate, and we don't have real bats here, and I think it's even better, right, if we just flap our own wings there, and we don't have the deformation, of course, or we can make a little bit. Maybe you can do some cloth. Also,
you can sort of rotate it and translate
exactly,
it.
and that's the plan, and see how well does that work, and the depth of field, that's a very important aspect. Yeah, so that should all be part of it.
So is this the kind of system that you're gonna set up in the tunnel and leave it there, or is it gonna be portable?
So it's made to be portable. Right, but I mean, there's then 50 cameras like that.
Yeah, but can you take individual ones or a couple of them? Can I take them to the jungle?
If you bring them back in one piece, yeah. Sure, I mean,
They'll be in one piece and maybe mobile.
But I mean, in principle, that is the idea. I mean, the NSF would like to have it sort of at one piece. So because you get the money also not to sort of supply a lab, but to build one instrument. So we had to really in the proposal repeat that mantra, all the pieces will become one instrument. I mean, we have 3 cameras that were actually not bought from the NSF, so you could certainly borrow those. And the idea is indeed that it could be flexible, that we can set up the frames in different configuration, that we can take it. I mean, getting animals from one country to another is a nightmare. Right? Getting 50 cameras is a lot easier, right? So that is indeed the idea and the way we are thinking. Right? So the first spot to deploy it is probably in Brunei and at the university there. And the idea is that we take the cameras there, but we buy new aluminum there. So we don't want to fly to Brunei with I don't know 100 meters worth of aluminum rails. We would buy that locally. And then I don't know about the connectors. Maybe we can take those. So we take the cameras, we take the lights, we take the connectors, we take the line drivers, whatever electronics we need, and then we buy the cables and the aluminum rails locally and put it together. And it's not exactly right that you can, like a tent, get it done in 5 minutes or so. It will be more work than that. So you probably don't want to move it once a week. So, but the idea is it can be moved and it can be used in different places, absolutely. And then if you set it up, right, again, I won't tell, or if you don't need all 50 cameras, that will also be, I guess that'd be okay, right? So, and again, we have 3 extra cameras, and I mean, with 3 cameras, you can also do a lot of things, right? You can see a lot of things from a lot of angles. So everybody should know that there is already this small system over the summer. We used past summer. We used it for the dead drinking experiments. So that system is also available. I mean, we could even mix, right? We could input some color cameras together with the non-color ones, and sort of merge that information in the future. So we have these capabilities, and the idea is really that you use them and you configure them based on what experiment you want to do, right? And the software should be adaptable, right? If you can use the same software with just 3 cameras, but you might have more occlusion then. But depending on what the animal does, it might actually be good enough, right? So let's see about that. Any other comments? Okay.
So how are you guys planning to remove the data from the camera? So far, there's an SD card in there.
No, it has a built-in storage, and
so which is a RAM. But how are you going to export that out?
We will have to figure it out.
But it has an Ethernet port.
So
yeah.
I was going to make a comment about that because in the picture it said it was not supported at the current firmware. So I don't know if the picture was the old picture. So I mean, if you can do it, if that's like even a 10 gigabit or whatever, you just dump the data.
Yeah. So I understand that the software is indeed, we did a firmware update already over the summer. So it's a good point that we need to check on that.
Yeah.
But then probably before we place the big order. I understand that this is working now. That's what David, the owner of Contact, what he promised me. But we should check on it. But so indeed, right, so if you have 2 cameras, you can just carry them around, or they carry the SD cards. But if you record with 50 cameras, you don't want after every.
So how much is the onboard memory?
16 gigabytes.
16
and that will do for 8 seconds of recording.
8 seconds?
Yes.
That's quite a bit.
That's quite a bit.
The flight is typically 1 or 2 seconds.
Yeah, and then you want to record a little bit longer. But yes, so we could definitely shoot one pretty long flight with a little bit lead time and a little bit at the end. So so the idea is really that the onboard memory holds one experiment, but then we really need a host computer that can talk to all those cameras over Ethernet and says, you send me your stuff now, right? And then we need a fast router, fast switch to make sure we can get all that data off. So it's a really good point, and that's something that Gorja and Xiaoyan, right? So since you started just last week is okay. If you say, I don't know, but that has in the next couple of days, Gorja, that has to change, right? So even if you're not the electronics person, right? So at the level of the ports and what they do and how you can use them, right? You definitely have to familiarize yourself with that.
Just one small comment. I think somewhere it was mentioned that the file system is a FAT32 file system. There are file size restrictions with FAT32. There's a later version called extract that doesn't have the file size restriction. If you have the ability to format it to extract, that will probably be better. You wouldn't have any file size restrictions.
I'm pretty sure the 16 gigabytes is pretty much, it acts as an active buffer. So I don't think they do any encoding. It encodes in that you save it in a raw format, right? Or does it do encoding on the fly?
I would think that this is a raw file.
Yeah, so you don't have to worry about that file size restriction.
But again, I mean, this is how things where we have to kick the tires now and
so
see.
Currently, if Ethernet is not functioning, how do you see what the camera sees?
Yeah, again, Ethernet has to function.
Yeah.
Right? That's really a condition because as a 50 camera array and no way to get it off, right? So that, and I believe it does actually with the last firmware update. But this is something that Guoxia and Xiaoyan, you wanted to get yourself familiar with the software. So please kick the tires on that very soon. So the data has to come off via Ethernet. It cannot be put in the SD file.
So how much data do you anticipate?
Yeah, that's what I'm
per
focused
run?
camera.
We did some calculation, but I forgot the number.
I don't know. Typically, we have now you'll have a lot more frames for sure. But say if it is a 3-4 second recording.
Yeah, 4-second recording is 200,000 images.
200,000 images.
And then we have to see what compression level, what can we, I mean, if we did it raw.
What I was going to say is even with Ethernet getting the data off the camera, it's a no small task and then it's stored.
Yeah, that's right. So we want sort of a file server next to the array that can swallow no but can use other funds for setting that up. So the idea is really to have a file server next to the array that has a few terabyte storage and then can swallow it. That's
I don't know.
Right.
okay, thank you very much, everybody. Okay, so work to do. So you got the idea of what you want to look at.
Oh no, just that's what.
And I think it has a extension. You can check if it can do that. And the idea can be we want to have that
I'm John.
Hi.
Hi.
Natalia, nice to meet you.
Have you been working with the high-speed camera?
Yes, I'm very. All my work is the frog stuff is my stuff. So.
Okay. So
I'm very familiar with syncing high-speed cameras, how all that works.
So how many cameras you're using?
I use 3.
3. All right. So are those like the large cameras?
Yeah, there were 2 photons, which are really large. They're old, and one edgertronic, which I assume is one of the ones you guys looked at for this grant.
Can I have an email address or something from you so that?
Yeah, I'm totally happy to. I'm also interested in, well, hopefully I'll be gone before